Hey Zion, I want to actually just take a look at the idea of solving variables on both sides of an equation. So if we come over here, here's our problem. I like to first just think about this as two separate sides where what's on this side is equal to what's on this side. And what I do before I even start a problem like this, well, once one side is as simple as possible, like there's no way to simplify this, and the other side is simple as possible, there's no way to simplify this right side. What I like to do is say one side is going to be for my x terms, and my other side, let me use a different color, is going to be for my constants. So my goal is to move things to where they belong. So if I want my x terms on this left side, this 3 needs to go away. How do I get rid of that 3? I'm going to add the opposite. I'm going to add a negative 3. What I do to one side, of course, I do to the other. When I'm done, I'm left with the constant here is gone. So I'm left with 2x on this side is equal to, this minus x is still here, but now I've got 15 minus 3, which gives me a constant value of, what's that going to be? 12. Good. And then what I'm going to do next is I need to get rid of the term here, this x term, because it's not a constant. So I'm going to do the opposite of what minus x is doing. I'm going to add x to both sides. When I do that, I'm left with 3x is equal to 12. Notice I only have orange or constant terms here, and I only have black or x terms here. And of course, we know what to do at the end of this. I'm going to divide both sides by the 3, and then I get that x is equal to, and just to be consistent, I'm going to say that x is equal to 4. So that's how I solve these types of problems. Now that we've done that problem, I'd like you to take a moment to try this next problem here. Let's call it number 2. Let me see if I can get my pen back. Let's do black. Let's call it number 2, and it'll be 7y plus 8 is equal to 4y minus 10. I need you to pause it here and then check to see if you get the answer right. I'm about to give the answer. The answer you should get is that y is equal to negative 6. If you need me to, take a look at how we got that. If you already got this answer, negative 6, then skip to the next example. So here what you would do is you're going to take a look at this. I like drawing a line. Notice both sides are as simple as possible. I'm going to choose the side where I want my y terms to be. I like to put my y terms where the most are. So I see that I've got 7 y's here. So my y terms are going to be on this side, and that's what I'm going to chill with over here. And my constants, the other numbers, are going to be on this side. Does it have to be like this? No. If you choose to switch them, that's okay. It can still work out fine. So I know that I only want y terms here, so this value of 8 has to go. How do I get rid of that 8? I've got to subtract 8 from both sides. When I do that, I'm left with 7y on this left side. These guys are gone. 4y is still here, but this together becomes negative 18 because this is a negative 10 plus a negative 8. So that's negative 18. I only want these orange or constant values here. This 4y has got to go. So in order to do that, I'll do the opposite. I'm going to subtract 4y from both sides. And then I get 3y is equal to negative 18. Let me do that in orange. Is equal to negative 18. Divide both sides by 3. And you can clearly see where my value of negative 6 came from. So if you got negative 6, I hope you skipped my little explanation and went down to this next example. If you didn't, I hope that made sense. Let's take a look at number 3. I'm going to do number 3 with you, and then we can talk about how we'll give you a chance to work through one like it. So number 3 is not pretty, but we can handle it. It's the same idea. So I see we've got a fraction here and a fraction over here, but there's nothing we can do to simplify either side, which is cool. I like to draw my line straight down the center so I can keep track of what's going on. I'm going to put my x terms on this side. This is a negative 1/4 x. This is a positive 2/3 x. So that tells me that more x's are over here. I don't have to do this, but it just kind of keeps things straight for me, and it makes sure that my x is always a positive value. And so since I'm putting my x terms on the right, I'm going to put my constants on the left. With that in mind, I do the same thing that I usually do. I decide what needs to go. What needs to go on this side? Well, I want my constant -6 to stay. I want to get rid of my -1/4 x. So to get rid of that -1/4 x, I've got to add a +1/4 x to both sides. Now this is where things get a little bit tricky because I know we don't always love fractions. So what's left on that right side after I'm done is a +6, matches, it's a constant. But what's left on the right side is going to be a little bit more complicated. So I come over here, here's my cheat sheet. I'm going to take 2/3 x and I'm going to add to that 1/4 x. Realize that's what I'm just doing this, I'm just adding these two things here. So I need a common denominator. When we add fractions, we need a common denominator. That's 12. There's another 12. And so 3 goes into 12 4 times. 4 times 2 is 8. So I can write 2/3 x as 8/12 x. And then 1/4 x can be written as 3/12 x because I multiply top and bottom by 3 to get this value. So now that I've got the common denominator, I can add them up and I see that this is just 11/12 x. So this is kind of a thought bubble on the side, or my little cheat sheet where I do some work. And so now I see that this thing here, this is equal to 11/12 x plus 28. And let me put my 28 in orange because it's a constant and I know it needs to go to the other side. How do I get rid of this +28? I'm going to subtract it, or I'm going to add the negative version of it, however you want to see that. 6 plus a -28 gives me a -22, and that's equal to this 11/12 x. How do I get x alone here? Do you remember? I've got to multiply by the reciprocal. So the reciprocal of 11/12 is 12/1. So when I'm 12/11, pardon me. So when I multiply by 12/11s, these guys cancel out and I'm left with just x. But what I do to one side, I've got to do to the other. So I'm going to multiply both sides by 12/11s. When I do this, I think your teacher told you about this cross canceling. 11 goes into 22 2 times. 11 goes into -22 -2 times. There's a 1 here. So I have 12 times -2 gives me a -24, and that's what x is equal. I know this looks like gobbledygook. I know this looks confusing, but I want you to process through it like we did. So I'm just going to talk about this again. This 6 and this -28 gave me that -22. And then when I brought down my 11/12 x, I had this, but I had to get rid of that. So I multiplied by the reciprocal, which is 12/11. I did it to both sides because when we're doing algebra, when we're solving problems, what we do to one side, we've got to do to the other to make sure that we have it balanced and it's equal. When I did that, I cross-canceled. I got this value here. X was now alone, and I have that as my answer. So hopefully that feels good. I'm going to give you a chance to try one on your own. So Zion, here's your problem. You're looking at 2/5 x minus 8 is equal to 20 plus 3/4 x. The answer, you can pause me if you want to wait, but the answer I'm going to give you right now is x is equal to -80. And if you got that right, you are done with the lesson. You should feel good about doing these problems. If it didn't come out right, then please take a look at the next work that we're going to do. So we'll answer it together. So I'm going to erase the answer here, and let's get started. Whenever we have a problem like this, we want to draw a line straight down the center. Notice that this side is as simple as possible. I can't join like terms because I don't have any. Same thing over here, nothing to join. I'm going to choose what side I want my x terms on. I'm going to put my x terms over here. It's okay, doesn't matter what side you put them on, but I like to put it where, again, I think that there are more x's in a sense. My constants will go on this side. And with that in mind, I'm going to start working. If I want constants here, what needs to go? Hopefully you said the 2/5 x. So I'm going to subtract that away. What I do to one side, I've got to do to the other. I'm going to need a moment with my cheat sheet over here to figure out how to do this subtraction, but that's not too bad. When I'm done on the left side, I have a negative 8 left, and that is equal to, well, we're going to find that out in a second. So over here in my little cheat sheet, I'm going to take my 3/4 x, and I'm going to subtract from that 2/5 x. And I want to have a common denominator. This is a 4. My common denominator would be 20. So this 3/4 is actually going to turn into 15/20, and this 2/5 turns into, well, 5 goes into 20 4 times 4 times 2 is 8, so I get 8/20 x. So I'm going to subtract these. 15 minus 8 is going to give me 7, so I'm left with 7/20 x. So that's the result that I should get here. So I have 7/20 x, and it's positive, so I'm going to put a plus sign there, plus 20. Got to get rid of that 20. That 20 is a constant term. It doesn't belong on this side, so I'm going to subtract 20 from both sides. When I do that, I am left with, on the right side, 7/20 x, and then over here, I'm left with the constant value of negative 28, which is pretty cool. How did we handle it last time? And the last problem, when we had a coefficient that was a fraction, we had to multiply by the reciprocal. And I'm going to do that here. This is looking like an 8. I want you to know that's a 20. All right, so when I multiply this side by the reciprocal, I get 20/7. What I do to one side, I definitely do to the other. I get 20/7 here. The 20s cancel, so do the 7s, leaving me x, which is what my goal was the whole time. I'm going to draw this down a little bit. Slide that down. Okay, so I'm left with x on the right side. On the left side, I've got this, but we can handle it. This looks like an excellent situation for cross-canceling. 7 goes into negative 28, negative 4 times, and then I'm going to have 20 times negative 4, which is negative 80. And that's how x is equal to negative 80. I hope this made sense. I hope this was a good little preview or a little bit of a reminder of some of the things that you will be doing in class this week. I'll talk to you soon, Zion. Have a good one.